Hello, everybody. We are going to be recording this lesson right now, and just letting you know that we're recording. Somebody let Mia know we're recording right now, and we're going to be learning this topic right here called dimensional analysis, DA for short. Okay, dimensional analysis. It's a fancy word. Fancy word just means like the way. It means a way. A way to do what, you say? It's a way to convert units. Why are we learning it? Well, chemists use it. Okay, and what really the power of dimensional analysis is that it can make that says it can make difficult problems easier to solve. Okay, dimensional analysis can make difficult problems easier to solve. Things you'll need, you'll need a calculator. There's an online calculator on Canvas under important resources, but you can use a calculator right now. Remember, this lesson is not about math. This lesson is not about punching buttons in the calculator correctly. This lesson is about learning dimensional analysis, which is a way to convert units. So it's about learning a way to show your work as well. So the basic idea, the basic idea of dimensional analysis starts with this definition of a conversion factor. A conversion factor is, or can be defined as, this is my definition, you can find another definition if you want, but two measurements with different values and units that that have the same meaning. Okay, we'll give a few examples so you're not confused. Conversion factor. This is the big part of what dimensional analysis is a conversion factor. There's two measurements with different values and units that have the same meaning. Here's an example of a measurement, 60 S. And the S stands for seconds, okay? So we're gonna break this down into the different words that are in the conversion factor definition. The 60, just the number is called the value. Okay, then the S, that's called the unit. This is what separates math from science. Okay, in science class there's units. You put them together, that makes a measurement. Okay, so 60 seconds, that's a measurement. It measures a time. 60 seconds is the same as equals 1 minute. We should all know that in our experience in life. 60 seconds equals 1 minute. This is called a conversion factor. There are two measurements with different values and units that have the same meaning. Different value, different unit, same meaning. Okay? Conversion factors are also, another word for a conversion factor is called an equivalence statement, but that's like fancy and it's a big word, so we're not talking about that. Equivalence statement, it means that they're equal. It's two different statements that are equal. Okay? Here's another example, 12 inches. You probably already know where this is going, but we're not gonna write equals. We're gonna write the conversion factor like this. 12 inches per, that means per 1 foot. And this is actually the way that we're gonna see conversion factors written all the time. So if there's 12 inches per 1 foot, that means 1 foot, for every 1 foot there are 12 inches. And conversion factors can work like this. They can be flipped upside down depending on what unit you're trying to convert, what unit you're trying to solve for. Okay, I'll give you examples in a little bit. But to be sure, let's drive the point home. MPH, that means miles per hour. So say you're driving 20 miles per hour. The miles per hour, PH, means that it can be written like this. 20 miles per every 1 hour. Okay, and sometimes conversion factors, actually all the time, I will write conversion factors in parentheses. They'll be in parentheses because there's going to be mathematical operations happening to them. They'll be multiplied. There's going to be numbers multiplied by conversion factors. Okay. So 20 miles per hour, that's the same as, if I can travel 20 miles in 1 hour and I keep that rate of speed, that means if I have 1 hour to travel, I'll be going 20 miles. You might think this is redundant, but it's not. Okay, 20 miles per hour is the same as 1 hour per every 20 miles. Those are the same things. They're equivalent statements. They're a conversion factor. Okay, so you're about on average 15 and a half years old, 15.5 years old. So what I'm going to do is use a conversion factor to figure out how many days you've been alive. So 15.5 years old. We're going to put that over the number 1. Now, we want to convert 15.5 years into days. So we need a conversion factor that lets us know how many days there are per year. You probably already know it. There's 365 days per 1 year. That's exactly how we write it in the conversion factor. So we multiply 15.5 times 365 days per 1 year. Now stop thinking about math. It's not about math. It's about knowing how to write the units and where you put the units in the conversion factor, okay? So the skill you're gaining, the skill you're gaining is to show your work like this. The skill you're gaining is to know that you are taking the numerator here and you're multiplying across the numerator. And what you're doing is you're canceling out the unit year because the unit year is on the top and the bottom of this dividing line. And if you have the same thing on the top and the bottom of a dividing line, that means you can cancel it out. So we're canceling out the unit year, that's a Y for year, and we're circling the unit day because that's what we want to solve for. We want to figure out how many days you've been alive. So you can go on the calculator and you can add 365 plus 365 plus 365. You can do that 15 and a half times. Or you can use a more powerful mathematical operation, which is multiplication, 15.5 times 365. So with your calculator, you should type it in like this, 15.5 times 365 equals, and that gives us our answer, which is approximately 5,657.5, and the most important part is D for days. Doesn't seem like a lot of days, huh, that you've been alive. 5,000 days? Wow, it's crazy. It's not that much. Well, what if I didn't want to stop here? What if I wanted to keep going and figure out how many hours you've been alive in your life? Well, if we know we've been alive approximately 15 and a half years, it's 5,657.5 days. Well, now we need a conversion factor that converts days to hours. And you're probably smart enough to figure this out. We're going to multiply by our conversion factor, which is what? 24 hours per every 1 day. Okay? Now you multiply across just like you did earlier, and you're canceling out the units that are on the top and the bottom of this big dividing line right here. If there's anything in the numerator that's the same as the denominator, you can cancel them out because they divide each other away. We're left with hours as our unit. That's the skill you're gaining for dimensional analysis. You're multiplying a measurement by a conversion factor to get a new measurement that's the same as the original. Okay? So 5,650, that has the same meaning as the original. So multiply them together and you get approximately 135,000 780 hours of life that you've lived. Wow, that's crazy. You haven't even lived 250,000 hours in your life. Weird, weird world to think about. But what we need to remember is that you're just multiplying a measurement by a conversion factor, which means that these two numbers have the same meaning. And actually, all of these measurements have the same meaning. They're just different values and different units. They all have the same meaning. Okay. Now you're going to learn that you could use more than one conversion factor in a row. You can squish them together without solving for each conversion factor. So for example, what if there are, let's do this big number, ready? Big number, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are, what number is this? 123,456,789 seconds. That's in the numerator, so we're going to put it over the number 1. I want to know how many years. How many years is that? How many years is 123,456,789 seconds? Well, if you knew the conversion factor that converted seconds to years, you would just be able to give me one conversion factor. But since we don't know the conversion factor that gives us seconds to years, we're going to put a few conversion factors in there. So what's a unit that gets me closer to years? Well, I need to pick a unit that's larger than seconds, so minutes, right? Now here's the tricky part. Here's a tricky part that you're learning about conversion factors. The unit that you're converting from needs to cancel out on the bottom, just like this. And the unit you're converting to needs to stay on the top. So now that you know where the units go, then you can place the correct value for a correct measurement. So we're not going to say 60 minutes per 1 second. We don't want to be multiplying this number. We want to divide the number, and we know that there's 1 minute for every 60 seconds. Okay, so this math will give us the correct answer, and what you do on the calculator is you divide. So that would be the number 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we have to do with conversion factors is multiply across the numerator and then divide by the denominator. So since we know that 1 times anything is itself, we don't need to multiply across the numerator. Let's just divide by the denominator. So that's divided by 60. And that gives us a big answer. I'm not going to write that answer down because that answer just tells me how many minutes there is. I want to know how many years there are. So what I could do is just put another conversion factor right next to it, slap another conversion factor right next to it. And does anybody know how many minutes there are per year? Probably not. I don't have that information memorized, but I do know how many minutes there are per hour. 60 minutes per 1 hour. And if I continue on, I do know how many hours there are per day. And then finally, I know how many days there are per year. So if you fill in the values to those units correctly, you'll get something like this. Okay, it's the numbers on the bottom this time. It's not on the top like in this conversion factor because we're converting a smaller unit to a larger unit. We want to divide by the number this time. We don't want to multiply by the number. So cancel out all the units that are on the top and the bottom. The seconds cancel. The minutes can cancel. The hours can cancel out. The days can cancel out. You're left with Y for years. All right. And basically, you go through each conversion factor with a calculator. Now if you know your order of operations, there are other ways to solve for this, but the way I like to solve for it gives me the most information. So here's the first answer. This lets me know how many minutes there were in that many seconds. What does it say? What number is that? 2,057,613 minutes. To figure out how many hours there are, we need to divide by 60 again. So I'm going to take that answer and push divide by 60. And that equals 34,293 days. Oh, wait, no. Wait, was I in hours? I'm just going to start from the beginning because I forgot where I was at. So let's start from the very beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to divide by 60. That tells us how many minutes there are. We need to divide by 60. That tells us how many hours there are. We need to divide by 24. That tells us how many days there are. 1,428 days. And then we need to divide by 365. And that tells us that there's 3.9 years, 3.91 years, almost 4 years. 3.91 years. So your entire, oh, that's kind of neat. This is like almost your entire high school experience is that many seconds. 123,456,789 seconds is pretty much your high school experience, pretty close to being the total amount of time that you'll experience in high school. Okay, so there's that. Let's do, where'd it go? Where'd it go? There it is. Okay, so we're gonna do these notes, one moment. All right, students, we're recording, and what's happening here is that we are getting these notes out. These notes are under Unit 1 notes, and they are titled Intro to Dimensional Analysis in Unit 1 notes on Canvas. Okay, so now we got word problems, and we're going to do dimensional analysis with word problems. I'm going to do a few problems for you, and then you'll have time to practice these notes, or these problems that are found in Unit 1 notes. Okay, it says a certain pie recipe calls for 3 eggs for every pie, and asks how many eggs need to be bought to make 5 of the pies for a birthday party. So in this box, what you're going to do is you're going to put the conversion factor. So I'm reading the problem, and it says a certain pie recipe calls for 3 eggs for every pie. What that means is 3 eggs for every 1 pie. So in this box, on every problem, you're going to right the conversion factor. Now, the question is asking how many eggs. So I know that I need to solve for a number of eggs. So on the right-hand side, I'm going to put an equal sign, and I'm going to put E for eggs over there. Okay? The question asks how many eggs need to be bought to make 5 of the pies. So I want to know how many eggs do I need to make 5 of the pies for a birthday party. Well, the conversion factor says there's 3 eggs for every 1 pie. So what I need to do is take the measurement that needs to be converted and put that on the left side over the number 1. So 5 pies need to be converted into eggs. We're trying to figure out how many eggs there are for 5 pies. We're going to put that over the number 1 to show this in the numerator. Then we need to multiply by the conversion factor. So the conversion factor you can put in parentheses. And the conversion factor is 3 eggs for every 1 pie. And notice that the P for pie goes on the denominator, and the E for eggs goes on the numerator. So we're left with the E for eggs. We multiply across the top, and very simply, we know that there's 15 eggs that go with 5 pies. 15 eggs can make 5 pies, because we know the recipe calls for 3 eggs for every 1 pie. All right, that's how it works. You could pause the video when you want and try and answer the next questions, but I'm going to go through them real quick. Yeah, so there are 35 students in every class at Wilson High School. How many students are in 20 classes? So I know that I'm solving for students. I know that I want to try and figure out how many students there are in 20 classes. So 20 classes is what needs to be converted into students. Well, what's the conversion factor? Well, the conversion factor starts with tells us in the problem there are 35 students in every class. So the conversion factor is 35 students in every 1 class. All right, multiply the conversion factor. We get 35 students for every 1 class. Notice that the units cancel correctly. Now remember, the conversion factor can be flipped upside down. So that means, yeah, you can flip it upside down in these other problems. There are 700 students in 20 classes. All right, your job is to do problem 3, 4, and 5 for your homework. And that is it.